Okay, so I've got another question to do with using integration mechanics. So the velocity of a particle is given by v equals 5 subtract 3t squared, where t is equal to or greater than 0. We're going to find the distance travelled by the particle in the third second of motion. So essentially this question is to do with integrating between t equals 2 and t equals 3, because that is the third second. Before we do that, we want to sketch the graph of what's going on here, because with integration we'll be careful about positives and negatives. Maybe things will cancel out, so we want to see, is it wholly above the x-axis or wholly below the x-axis, or do we need to be a bit clever about this? Okay, so a quick sketch of what's going on. So when t is 0, velocity would just be 5, so we'd be starting there. We want to find the roots to this equation to find out where we cross the axes, and that's going to tell us if we've got like t equals 2 and 3 here, in which case it'd be complicated, or maybe they're both here somewhere, in which case it's fairly easy. Okay, so we want 5 take 3t squared to equal 0, therefore t squared is 5 thirds, t is then square root of 5 thirds, which is 1.29. In fact, that should be plus or minus here, so in fact the roots aren't here and here. The roots would be 1 over here, which is kind of not part of it really, because t is greater than 0. And the graph's kind of this shape. And we're solving this 1.29, so t equals 2 might be like here, t equals 3 somewhere over here, and we're going to integrate between those 2 points, which are going to find this area. No, when we do the actual integration, we get a negative because it's below the axis, but then we obviously just make it into a positive to decide what the distance is. So we want to integrate between 2 and 3. 5 take 3t squared with respect to t. So that would give us 5t subtract t cubed between those two limits, which we will then substitute in. So we're going to get 5 times 3 take 3 cubed subtract 5 times 2 subtract 2 cubed. So 15 take 27 subtract 10 take 8, or minus 12 subtract 2, which is minus 14. So the actual distance will be the positive version of that, which is 14 meters.